Hi class, I want to do a quick introduction to triple integrals, talking about using Fubini's theorem here. So just as for double integrals, the practical method for evaluating triple integrals is to express them as iterated integrals as following. So it's just really simply, if f is continuous on a rectangular box that's defined as a to b to c to d to r to s, then if we want to construct the triple integral over that rectangular box, these values here are just going to be our bounds of integration. Okay, so notice it's x, then y, then z. So we're going to go the integral from r to s, that's the dz, the outer, c to d, that's the y in the middle here, and then a to b, the x values, dx here. And then we're just going to integrate the function. And as always, when we go to integrate x, we're going to hold y and z constant. When we go to integrate y, we're going to hold z constant, and we'll be able to finish from there. All right, so it doesn't always have to be dx, dy, dz. So there are 5 other possible orders for which we can integrate, all of which will give the same value. Okay, so for instance, if we integrate with respect to y, then z, then dx, we're just going to switch the bounds of integration as such. So it's not a big deal. And no matter what way you do it, you'll always get the correct answer. Some ways will be easier than others, just like we've seen with the double integrals. You know, sometimes it's easier to integrate dy dx than dx dy. Okay, let's just do a quick simple problem here. Let's evaluate the triple integral here across the box B, and the integral is the function x, y, z squared. All right, where B is the rectangular box given by x is going to vary from 0 to 1, y is going to go from -1 to 2, and z is going to go from 0 to 3. So all we're going to do is we're going to set our bounds of integration. We're going to go dx, dy, dz. Okay, it doesn't matter which way we do it, but we'll do it that way. So the z bounds go on the outside, the middle is the y, and the initial integral is the x's. So from here you just have to follow the integration. All right, so first thing we're going to do is integrate with respect to x. So x becomes x squared over 2. And then what we're doing is we're plugging in these values for x. Okay, so when we plug in using the fundamental theorem of calculus, the 0 knocks that out. We plug in 1, we get y, z squared over 2. Now we're going to integrate with respect to y. So the z squared is constant. So this just becomes y squared. 2 times 2 gets us 4. We're going to plug in these bounds for y, leaving z constant. When you plug these in and clean it up a little, you're going to get the following. Then the last thing you have to do is just integrate with respect to z. And this just very simply integrates as z cubed over 3. The 3 cancels here. So you're just left with z cubed over 4, evaluated from 0 to 3. Well, you plug in the 0, that goes away. And z cubed is equal to 27. So it's pretty straightforward. Basically, all you're really doing is just a double integral with an extra part to it, just the z variable. So just the same methods as you were doing before.